All right, now we're into the last part of syllabus 5.3, and we're talking about the two variations of cosine rule. So if you look at cosine rule, it's just an extension of Pythagorean theorem for non-right triangles. So here's the cosine rule. If you're curious about the proof, ask me and I can show you, but it's not part of this syllabus, so we're just going to go with the fact that this is the cosine rule. So a squared plus b squared minus 2ab cos c equals c squared. And remember, with an equal sign, it doesn't matter what's on the left, what's on the right. I can always switch places of those. Also, since it's non-right triangles, the letters don't matter. So I could rearrange this to have cosine A. So instead of c, I could have a here. So a squared plus b squared plus c, a squared equals b squared plus c squared minus 2bc cos A. So the trick with cosine rule is that I always have matching letters on the outside. So angle C matches with side C, opposite sides of the equal sign. Angle A matches with cos A. Angle A matches with side A. I could also do the same thing with B and B. So I can rearrange this version to get my cosine A by itself. And your formula book shows you both of these versions. So if we look at our formula book, we see we get both versions with the A's. So let's see where this version came from. All right, if I start with this formula, so I'm just going to rewrite it down here. A squared equals b squared plus c squared minus 2bc cos A. So capital A for the angle, cosine, and of course this is all being multiplied, so there's an imaginary multiplication sign there. I want to get this cos A by itself. Well, to get this by itself, this is being subtracted. I'm going to add this whole thing to the other side. So plus 2bc times cos A plus 2bc times cos A. So on this left-hand side, I'll have 2bc cos A plus a squared equals b squared plus c squared, because this all canceled. I'm trying to get this cos A by itself, so now I'm going to subtract a squared from both sides. So now I'm going to have the a squareds cancel. So I've got 2bc times cos A equals b squared plus c squared minus a squared. I want the cos A by itself. The opposite of multiplication is division, so I'm going to divide both sides by 2bc. Then my 2bc cancels on the left side, and now I'm left with this formula. So cos A, let me go back to my blue. Cos A is b squared plus c squared minus a squared divided by 2bc. So this is the version that I'm going to use when I want to know the angle. And I have all three sides. I'm going to use this version of the formula when I know two sides and one angle. So we're going to look at that in some of the next examples, but let me write that down. So use when we want a side and know two sides and angle in between. So we call that the included angle. It's the same idea as when I want to know the area. So I use cosine rule to find the side. If I know those two sides in the included angle, I could also find the area using my area formula up here. All right, so in the next video, we'll look at examples.